We have made our floor plan, which is not in the scope of an electrical engineer, or it is not the scope of an electrical design engineer either. This was just to give you an insight. So after this, the electrical designing starts. Either the owner directly involves the design engineer, or what happens is he hires an architect and he then hires the relevant engineers. Like an architect would make a design and would hire the structural engineers, there are civil engineers, and then mechanical engineers for plumbing, and then electrical engineers for power and lighting design. So in such cases, when an architect hires an electrical engineer, he usually provides them with the RCP, which is the reflected ceiling plan. Let me simply explain what is reflected ceiling plan. A reflected ceiling plan is simply, you will see this ceiling, you would see lights on the ceiling, like the position of lights. So this position of lights is not decided by the electrical design engineer, but this is decided by the architect himself. So what an electrical design engineer does is he just places the lights of different wattages and try to achieve a certain lighting level. So before we begin lighting design of this house, let's just discuss some key concepts about lighting design. So what lighting design is? Lighting design is simply placing the lights and achieving a certain lighting level. So what is lighting level, how it is measured, and what are the key factors that are considered before lighting design. So we are going to discuss all these things in these key concepts. For lighting design, we need to consider these following things, which are the kind of activity area and whether area is indoor or outdoor. So the kind of activity area is, you know that if I am working in a laboratory, I need a certain lighting level, or I need certain brightness at my working surface. And if I am sitting casually in my house, I don't need that light. That lighting level or the brightness of light is not that critical. And also, if I am sitting in a laboratory or in an office, then the light should give a certain environment. And if I am in a restaurant, then the light should give me, it should give me a cozy effect. That shouldn't be in office. Like if I'll have cozy environment in the office through lights, then this might make me lazy. But if I am having this while I'm having my dinner, that would, that is a plus for a restaurant. So, and the other factor, which is whether area is indoor or outdoor, this is because we can then light our system, or we can light our floor plan or whatever we are lighting according, considering the amount of light that we are getting from the external sources. Even if the area is outdoor and the sun is not there, there may be street lights or lights coming from the neighboring houses or neighboring lights, right? So, and all, or I'll have to have the lights that are energy efficient, that would change their lumens or their lighting wattages with the time of the day, right? That may change their lighting levels with the time of the day, right? So I will have to consider if the area is indoor or outdoor. So we have discussed here three things: that I need to have a certain lighting level, that is brightness in simpler words, and I need to have certain effect from the lights, and I need to know what activity area this is. For this for these two things, I need to know the activity area, and also I need to know whether the area is indoor or outdoor. Now, for lighting design, the first two terminologies, or the first two things that are considered, is the standard lighting level, and the other term is lighting power density. Lighting level, that is measured in lux, and the other term is lighting power density. I'm not considering light level in feet candela, feet candela because we do not consider these units. The standard units that we use are mostly lux. And let me tell you, this lux is not the fragrance that brings people closer. This has everything to do with light and nothing to do with the soap. So you may see here the bedroom or dormitory has 200 to 300 lux, and LPD or watt per square feet is 0.58. You may for cafeteria it is also same. Classroom it is different, it is more than the bedroom. And corridor is 50 to 100. Then for gymnasium it is the same. For laboratories it is different. For office it is different. And we have certain lighting per power densities, and these are the standard lighting power densities. This is the IESNA level of lighting power densities, etc. Now let's learn some confusing terms first, and then we will understand what lux is and then what lighting power density is. But as name has suggested, lighting power density is watt per square feet. That is, this is to be maintained for energy efficiency, right? So I need to have zero point 0.5 wattages per square feet. So in order to understand lux and and the lighting level better, or let's just first learn some confusing terms. So here this is representing my light source. So you can say that this is a directional light. So the light that is emitted from this source is called luminous flux, and this is measured in lumens. And when the lumens of light strikes the unit area, then this is illuminance measured in lux, and this is actually lumens per unit area. So the last terminology is luminance, and luminance is the light that is reflected back to our eyes from all the surfaces that it strikes. So while lighting design, I will have to consider, I will have to maintain lighting power density and lux level at a standard level. That I need to meet certain lux level and the lighting power density. Now the question arises, how do I calculate lux? For calculating lux, I will make calculation surfaces at the height of our working plane, so which is usually 3 feet. So at the height of 3 feet we make calculation surfaces, and in our case we will be using Dialex Evo. So in Dialex Evo, if I'm making a room, then calculation surfaces are made automatically and I don't have to make a new calculation surface. It is not necessary that the lumens that are emitted from the light source are the lumens that I am getting, and these lumens are lost. Most of them, or sometimes a portion of them, is lost. The reason for this loss may be reflection of the surface. You can say the reflection of the working surface or the surfaces of the rooms. Say if you have your room lightly colored, then the reflection or the lumens that would be lost because they would be reflected back to the eyes, right? So the lumens that would be lost or trapped in those colors or absorbed by the colors would be lesser. And say for example I have more mirrors in my room, then also the lumen loss would be lesser. And if I have a bulb or my luminaire enclosed in a fixture and that fixture is itself frosted, then also my lumens would be lost in that frosting, that they won't be able to escape the fixture. It also depends upon if what is the texture of my reflecting surfaces. Say for example I have marble flooring or tiled flooring, and then the reflectance of those floors would be more. And say for example I have my whole house painted with oil paint, then oil paint is usually smoother than the normal paint. So distemper or the normal paint, then and the reflectance would be more. So the final word is the color, the texture, and also the frosting of the fixture. It all depends, contributes to the loss of the lumen. The other factor is shape of the surface. So say for example I have my fixture that is shaped in omnidirection, For the omnidirectional light travel, that is, it is oval in shape or round in shape, then it would let the light or lumens go in all directions. But say for example my half fixture is metallic, then only half of the light would be able to escape the fixture. And if my surfaces are such that the shape of the surface is trap light, say for example I have so many boxes placed in dark colored boxes placed in my room, then obviously a lot of amount of light would be lost, so my lux level would change depending upon these factors. And the last factor is dust accumulated, or in case of kitchen, the grease accumulated on the reflecting surfaces. So if you have an environment that is dusty, then you would notice that the dust deposits on the fixtures, or dust deposits on the working surfaces or reflecting surfaces, that is walls and etc. And same is the case of kitchen. So these two, that is dust and grease, would reduce the reflectance of the surfaces, and they will cause lux levels to reduce, or you can say that they will absorb the lumens that are emitted from the light source. Now, keeping in mind these things, we will have to recalculate the lux by considering different factors. So the revised formula of lux is going to be lumens time utilization factor times maintenance factor over area. So utilization factor is something that we can calculate, and maintenance factor is a preset value that depends upon room surface maintenance, that at what interval you clean your surfaces. And then luminary maintenance factor. Luminary maintenance factor is, say for example I am having 5 bulbs. I initially designed my room with 5 luminaires, and then what happens is one of them gets out of service, and I never changed the faulty bulb. So then what should have 5 bulbs now have 4 bulbs. So at what intervals I am maintaining my luminaire or bulbs. Then other is lamp maintenance factor. Then this is the cleaning of the lamp fixture, the total fixture, that is the enclosure of the bulb. And then the lamp survival factor, that is what is the life of your bulb. You might have noticed that the LED that you buy for your house, it gets dimmer over time. So what is the rate of decline of the lumens that it produces? So this is the lamp survival factors. Maintenance factor is kept at zero point 0.8, and utilization factor can be calculated or can be found out by inserting or giving the software textures, colors, and all the and making all the reflecting surfaces in the house that are supposed to be there. So this is all from this part, and we will discuss the remaining concepts in the next video. I hope you understood, and if you didn't, you can always ask in the comment section what you didn't understand, and I will try to answer and solve your queries. Thanks for watching.